I'm here in Poughkeepsie. We're here to look at a different kind of computer from IBM. This computer reaches far into the past and is also super interesting. I'm super excited because I got a chance to talk with some insiders at IBM about all things mainframe. And mainframes are special to me. I'll explain why. You might not realize it, but around 70% of credit card transactions run on a mainframe. Financial institutions, banks, anything where it cannot go down generally is running on a mainframe. Businesses depend on mainframes. Businesses depend on mainframes that are distributed across the country. And even though they're distributed across the country, they're able to maintain transactional coherence, even separated as they are. This is why mainframes are so special and they're so important.
Now, a mainframe is not a general purpose computer. Okay, it's designed for really three things. Transaction processing, okay, which is highly important. Okay, database serving, it excels at those two things. And then what we call mixed workload. Those are customers that have multiple applications like transaction processing, data serving. The mainframe knows how to prioritize the workload based on what the customer's priorities are. And it can do that dynamically to maintain a consistent level of service. What we do is this thing's engineered for 8 nines of reliability, meaning the downtime is less than a couple seconds a year.
For IBM and IBM customers, it's all about resilience and reliability and what they call 8 nines of reliability. That's 99.999999% uptime, a couple seconds a year of downtime. And for me, working on applications, that's very little downtime. It is an astonishing engineering accomplishment to be able to say that, yeah, that's what we build for.
90% of all credit card transactions and about 70% of all transactions by value worldwide go through the mainframe. So it probably would have been impossible for you to come to Poughkeepsie without using or interacting with a mainframe in some way.
I'm here at IBM Poughkeepsie. It's the center of all things mainframe.
It is. Welcome. I'm so glad to have you.
I'm here with Tina. Would you want to introduce yourself?
Yeah, I'm Tina Tarquinio, and I lead product for the IBM Z and LinuxONE mainframe business for IBM.
Yeah, most people don't realize the mainframe is not even x86. It's its own thing, but it just doesn't even bother.
Its own thing, yeah.
IBM LinuxONE. LinuxONE is a big part of the reason I'm here because it's Linux. We all love and Linux. Linux is good, but Linux on the mainframe, it's a little different context. It's the Linux goodness that we've all come to know and love, surrounded by the 8 nines of reliability of the IBM mainframe running on Telum processors. So it's not like it's Linux on x86, it's Linux on IBM's own thing here in Poughkeepsie. Now tell me about LinuxONE, because I'm super familiar with Linux, the audience is familiar with Linux, but how do we leverage the mainframe resiliency and extend that into Linux? Because I don't know if you know this, but it's a little bit of a wild west with Linux.
So Linux is Linux. You can run a full Linux stack, fully take advantage of OpenShift, Kubernetes, all of your favorite Linux tools, open source or not, all across the platform, which is really exciting. And what our clients are taking advantage of is the intense resiliency, which I already talked about, and our really unparalleled security, right? So we have what we call secure execution, which basically says even root administrators cannot access what's inside this secure execution environment, which if you think about Linux running in a cloud environment, even in a private cloud environment, this is really what our clients are looking for.
And this is, I think, my personal opinion is watching x86 try to build something like this it's been interesting watching those kind of secure enclaves evolve outside of the mainframe because it's kind of been there, done that for the mainframe since the 1960s.
Yeah, it's sort of in our DNA. That's how we design these systems, right? So when we introduce quantum safe encryption, to us, that's table stakes for where our clients are. And we want to make sure that as clients expand throughout the Linux ecosystem, either to support their ZOS applications or just in a full Linux stack, that they have that best of everything, right? They have this completely open, connected hybrid world, and underpinning it is the security and the resiliency. And to us, that's really exciting. If you look at the use cases our clients have, right, they're looking at, there's, banking or financial services type of transactions, but then they're starting to expand it into medical environments or, radiology, looking at images. And so you start to combine these things with AI, and you really have a powerhouse for how you can, have growth.
Now, the IBM Z series has its own operating system, really its own job control software that dates to literally the dawn of the computing age. And yeah, that's all well and good, but there's also LinuxONE, and Linux is not from the dawn of the computing age, and IBM owns and contributes to a significant part of the Linux ecosystem and contributes, code that everybody can use and open source software in general. But the thing that's special here is that IBM is able to run Linux in a resilient way inside their mainframe. And this enables a really nice sort of cross-pollination of functionality in terms of the IBM Z philosophy and all the cool stuff that you can run on Linux. So let's hear more about LinuxONE. So another thing with this launch is, LinuxONE has been around forever, but LinuxONE is also a big part of this launch, and it's because Linux is a first-class citizen, not just from the Red Hat angle. I mean, we know Red Hat from the virtualization side and all of the stuff that Red Hat has brought to virtualization, signed Windows drivers, all of the nuts and bolts stuff. But Linux on the mainframe with LinuxONE is kind of transformational for workloads that run in Linux.
Yeah, so when we first brought Linux on the platform around 25 years ago, there's nothing we sort of do like halfway in the mainframe world. So Linux is like an absolute, complete 100%, first-class citizen. It can run native, it can run in virtualized environment, and inherits all the benefits of our architecture. So the scalable, securable, resilient, that's all baked in.
Native on Telum.
Native on Telum and all the processors before and all the ones after. And so, we fully participate in the hybrid cloud, right? So you mentioned Red Hat and, OpenShift. So we just made a few new announcements around OpenShift Vert, OpenShift AI will be coming. These are all really exciting things, but also there's a full open source ecosystem out there that we participate. We have a team of people that help get new, ISVs or products on the platform. And, there's tons of people in the LinuxONE and IBM Z community that are out there talking about what they can do. But it's really exciting. And a lot of our clients run ZOS and Linux side by side. They have done that for a long time. And then in LinuxONE, they can run it, full Linux environment. And we support, multiple distros. So really exciting.
I know, I don't want Red Hat. I want to run SUSE. And it's, okay, whatever.
Yeah, we don't want to predict that, right? Our clients make choices and we want to support them in what they need to do, so.
Makes sense, yeah. And now the IBM Z17 is launching. That's the next generation of mainframe. And IBM is layering on AI functions for transaction processing. IBM and Visa were talking about AI for fraud detection at GTC and how IBM and Visa together are actually making money on AI. That was a packed room. The people had to wait in the hallway because people were so interested in somebody actually making money on AI. But IBM is also using AI to make the mainframe more accessible and more user-friendly. I'm here with Andy, and we're going to talk about DevOps and generative AI and all sorts of stuff that, when you say generative AI, people immediately tune out. But the use case here is a little different. It's a little different than what you're thinking because mainframe skills are not common. But you can use generative AI to ask questions and modernize old stuff onto more modern things and have a better workflow.
Right, exactly. It's a combination of how we're taking generative AI and applying that to multiple business problems that are incredibly difficult. It's not only modernizing code bases that have been around for several decades, but it's also how do you take that code and build it into a modern DevOps pipeline? How do you infuse Gen AI in testing? How do you take Gen AI and build out assistants and agents such that you can deliver more value for the same amount of investment dollar? If you don't have an understanding of the application and all the connective tissue and the different business logic that's there, how are you supposed to build unit tests, let alone functional tests, right? So that's something that we're doing in terms of leveraging Gen AI to build out those automated test cases.
When you look at, what can you do with generative AI, it really becomes about transforming the user experience on the platform. And now we can run things like Watson Code Assistant for Z. We can run things like Watson Assistant for Z on-prem with your data without having to take your data off platform, so that reduces risk for our clients, right?
So we can build a brain, basically. We've all seen Watson playing on Jeopardy, but this is taking your data, from on-site. It never actually goes to the cloud. It never really leaves the customer's control. That's the promise from IBM. And you can also ask the mainframe all kinds of stuff about your business, like how do I make my code better? Or we need to automate this because this breaks all the time. How do we have automated testing so we know if it's going to break before it breaks?
Yeah, so it hits both on the developers and operators alike. So Watson Assistant gives you a one-stop shop for your operators. And Watson Code Assistant speeds up the rate and pace of application modernization because it gives your developers a generative AI tool to understand code, to transform code. And you can do that all within IBM Z.
This is an AI to actually help us make the mainframe more effective and use it better. So it's something a little different. In fact, if you look at what we saw in Poughkeepsie, even just assembling the mainframes, like loading memory cards into the system, that's all done by robots meticulously. They take pictures of every single component and then they slot them in. Why? Because human assembly is too variable. And if there's a problem later, they can pull up a picture of the component that was inserted and just make sure that visually, is it okay? Is there anything visually that might indicate there's a problem? The robots doing it, they're doing it perfectly consistent, and that ups the reliability. This is the kind of thing that you have to worry about when you're engineering for 8 nines of reliability. I also had some questions around DevOps and continuous integration and things like Git in a modern development practice, because this is a world where COBOL is still a thing. And some of these code bases date back 20, 30 years. Some of the code bases date back to the 1960s. Foreshadowing. And so I wondered, what tools, what does that look like for IBM? How does IBM help new developers or people that have been in their careers 10 or 15 years get up to speed on all things mainframe, where the code is probably older than the person working on it? And AI was part of the answer there. IBM actually had a lot of interesting answers around DevOps and DevOps integration.
Yeah, absolutely. For IBM Z, understanding your applications, one part of that is understanding what data does your application have affinity to. Right? If you have an application that is accessing data on the mainframe regularly, then you'll have a much lower latency if you place that application close to the data. There may be some applications that don't have that same affinity for the data, and that may belong in public cloud, and that's a fit-for-purpose discussion. What's the best fit? Does it need the qualities of service, right? The security that Z provides, and if so, right, move that to Z. And so we see some clients repatriating, right, to LinuxONE, to IBM Z, and we see some moving, right, where they make sense. So it's about understanding the applications, understanding what data it has affinity to, moving them where they belong. And it's also about then connecting them. So it's really important as you're managing your hybrid environment, the tools, the DevOps, and the CI/CD pipelines. Also, right, knowing, can your hybrid applications access the data, right, in near real time when it makes sense. If your data scientist wants to access data, we can put it in the cache, right, on Z for near real-time data access wherever you need it without making a copy and increasing your security exposure by doing so.
Oh yeah, you don't want to accidentally upload the sensitive data to a public cloud just so your data scientists can do data analysis.
Absolutely.
Yeah. So if you have one of these systems and you want to use modern dev tools, IBM recognizes, yeah, not a problem. You want to run Visual Studio Code or other editors, you want to use command line editors, you want to do all of your administration and management from Linux, no problem, IBM has you covered. But now with these advanced AI tools, you can interrogate the system, and it will help you look at that legacy COBOL code base and understand what you can do to modernize it, understand what you can do to bring it a little bit forward, understand what you can do to modernize whatever service interfaces that it may have so that it's more well understood in your organization and maybe a little bit more well managed, and that you could run unit tests, modern integration tests and unit tests against an old code base. So the idea being here is that IBM customers have a way to leverage AI tools without actually sending anything to the cloud.
Absolutely. So, enterprise standardization is absolutely key for our clients, right? They want to be able to manage a Z system as an integral, critical part of their hybrid cloud and do so seamlessly and easily.
Nice. We also learned that a key tenet for IBM with their AI is the AI can say, I don't know. There's not, the answer to that question is ambiguous, or it's not in my training data set, which helps minimize or eliminate hallucinations.
Our developers, right, when they're using the Gen AI, something that IBM does that's different is if we don't know, we say we don't know. So as the developers are interacting with the system, right, especially when you're working on Z and you need, right, that code to work, you don't want hallucinations.
Forbidden
right?
zone.
If you ask the model a question and it doesn't have the information to answer, we will say we don't know. Right? We won't give you an answer with 20% confidence. Right? We will give you an answer that you can rely on, right, and bank that. Right?
We also learned with the launch of updated, LinuxONE tools and Z17, these tools also provide more integration points for other systems. Just because you have a mainframe doesn't mean everything needs to run on the mainframe. Sure, your business critical path stuff should run on the mainframe, but how do you decide which thing runs where? What's the surface area look like? This sounds like a DevOps problem, doesn't it? Well, yes, it is. DevOps integration, unit testing, testing that you need across a distributed data center, and IBM has tools to help you set up those kinds of tests and that kind of infrastructure, and to help all of your programmers understand where the rubber meets the road in terms of, is this something that is in the critical path on the mainframe system, or is this something that runs externally somewhere else? So these are not large, complicated systems. These are not systems that demand 120 kilowatts per rack. Putting the AI close to the Telum 2 processor is really about latency reduction. It's not about raw throughput. It's not about tokens per second. It's about giving those AI functions a little bit of room to breathe close to the processor that's in the mainframe, so that when it's doing transaction processing or it's doing your line of business calculation, that it has a little bit of AI capability right there where the other processes are running. Now, if you need something more elaborate than that, sure, you could go off system. The networking and other integration here is just fine with that. But it still provides AI functions in the critical path with that 8 nines of reliability in terms of making sure that whatever you've configured on the AI side of things will be always available to your business and your business's customers.
Look at the number of transactions that we all do, right? The smartphones that we all carry is nothing but transaction after transaction, many of which happen to be read transactions. So think about every time you open up your financial app. Right? What's the first thing that pops up? Your checking account balance, your portfolio balance, things like that. All of those are transactions. Even though we're not moving money or doing things, all of those are considered transactions. That's how we get to billions and billions of transactions every day.
Components are tested, torture tested for hours before they're made available to go into a system. So the components are, the circuit boards, the memory, everything's tested. Then a technician builds a system pretty much in a custom manner, meaning every single customer orders a unique configuration. How much memory they want, how many processor cores, how much I/O, what type of I/O, what kind of networking, all that kind of good stuff. And from that order, a bill of material kicks out for what the technician has to put into the system. And that robot that we just saw brings all the parts. So the technician doesn't have to go look for them. They're delivered right to him or her to build the system. When the system gets built, okay, it gets inspected, and I'll show you what we do to test it, okay? And the testing's cool. We do some things with testing that's sort of unheard of. You won't be able to see this here because we don't do it here, but we test the system to see if it can withstand an earthquake. There's a place in Reno, Nevada, where we actually ship a system to, and they put it on a machine where the thing simulates what an earthquake would look like, and they do it to make sure that the system stays running and stays operational. Because there's a lot of things in there, circuit boards, parts, things that are bolted, things that slide in and get clipped. You want to make sure that it can withstand that. And we've had things, where natural disasters occurred, where everything, quit except for the mainframe. It kept running because it's designed for that. Our customers depend on it. So that's part of what you're getting is the extreme reliability.
Now, in addition to your bank and your credit card processor and probably other businesses you interact with on a daily basis, airlines and more, that depend on their mainframes for most of their critical core line of business stuff, the federal government also depends on mainframes. And this is where I have a little bit of experience with mainframe systems. There's a program running, it's the oldest running program on planet Earth. It's called MOCAS. The federal government uses that to manage their contracts and their contract awards and their contract modifications. And I worked on a system that would detect and help correct errors in contracts and contract modifications that were submitted to the MOCAS system. And yeah, that's all COBOL. That's originally Grace Hopper. and literally the oldest program on planet Earth. And it gave me a new respect for mainframes because over the years, a lot of contractors had tried to replace that system and failed, varying levels of failure from catastrophic failure to abject failure. And mainframe systems really should command a lot of respect. Anytime you try to replace a mainframe, you should, have a warning counter. It's like, okay, we're going to increment the counter as a warning to the next people who say, oh, we should try to replace the mainframe with something else. Because it's hard to do that. You should have more respect for the mainframe. And MoCast is still alive and well today. I mean, sure, they've surrounded it with like an onion with many, many, many layers, but ultimately, everything eventually makes it back to that COBOL code base. And let me tell you, Grace Hopper's name, still on it. So I'm glad that I was able to connect with IBM and get some questions answered about LinuxONE and the new mainframe launch. And it's kind of been on my list to go look at this and do this for a long time because... and it's because of that work that I did a long time ago and my work on mainframe stuff in the past that I have a lot of respect for mainframes and where they've come from and all of the magic that is happening in Poughkeepsie and with the mainframe team. And I've had this is proof. It's a lot of fun. And I just wanted to share, it's one of those splinter of the mind things. It's like mainframes, you need to be aware of them. You should understand them. They are gentle and majestic creatures, but they are a force to be reckoned with. So it's a lot of fun. Thanks to the IBM team for hosting me. We might get some more content out of this. I don't know. It's a lot of fun. LinuxONE and some other cloud stuff, jumping. But yeah, I've had this book for longer than I care to admit. I'm Wendell. This is Level 1. I'm signing out, and you can find me in the Level 1 forums.